Alright, now we're gonna get into some basic differentiation rules. And what we used last time was the definition of a derivative, but it's complicated, it takes a long time, and you can make mistakes on it. And so we come up with these rules, and I don't really get into like the proofs of these rules, but you can find them online. The first one is the products rule, which is to just you basically take the or not the power rule, which you take the exponent, put it as the coefficient, and you subtract the exponent by 1. Say you have x to the fifth power, you take this 5, subtract 1, you get that. It is also important to note that the derivative of a constant is 0. Here's why. If you say y equals 5 as your function, and we draw that out on a graph, right, it just looks like this, right? That means the slope is just 0. It just never changes, and that's why the derivative is 0. Next, the sum and difference rule, and the sum and difference rule, which is literally just if you're taking the derivative of two different terms, you can just take them separately. Product rule is a little complicated. Basically, if you're taking the derivative of two functions, and what I mean by two functions is two functions that are multiplied by each other. Say it's like x to the third, x squared plus 5. Notice how our one function is this, our second function is that. What we do is we're given this formula, f prime, you take the derivative of one and the base function of the other, and you add that to the base function of the other and the derivative, or the base function of one and the derivative of the other. And the reason and how I organize it is I draw a little graph out, or a little table out. I label this f prime is equal, or f is equal to x to the third, g is equal to x squared plus 5. Cool. And then that's how I do that. Next is the quotient rule. It's the same thing as the product rule, but instead the two functions are divided by each other, and our formula looks like that. It's a little more complicated. And now let's just take the derivative of these. First one, you use the product rule. X to the third, you take this out, you subtract it by 1, you get this. Perfect. This one, nope. Let me pull up the answer key so I know I'm not making mistakes. Alright. Next one, same thing, power rule. Right, this time it has a coefficient, but we just multiply this 4 by 5 and we get 20, and then minus 1, and you get 3. Cool. Next one. Oh, why is there a gap? I gotta edit that out. Next time, there's two terms, but we can just take the power rule of both, and we get this. This one, product rule. X squared, and the derivative is 2x. 2x minus 5, derivative is 2. It's f prime of g plus g prime of f. F prime is 2x times 2x minus 5 plus x squared times, or 2x squared. And we'll just write it like that. Same thing. It's just the product rule, but a little more complicated. 3x squared, 2x to the fifth plus 3x squared is 10x to the fourth plus 6x. Then our derivative is this. Running out of space. That should be good. Just be aware that these do take practice to not mess up. So, I'm doing it quick right now, but then again, I've also had to practice, so just make sure you practice these. This one is f prime g minus f g prime over g squared. So then let's do the little table again. 6x to the fifth plus 3x. Oh, what am I doing? What's wrong? 10x, 6x to the fifth plus 3x, 30x to the fourth plus 3, and then 10x, 6x to the fifth plus 3x, minus, this time, 5x squared minus 3 times 30x to the 4 plus 3 over 6x to the 5 plus 3x squared. Boom! That is our answer. We are good. We are good. We are good. So just you can find practice problems online for each of these. I just did them pretty fast just to show you the examples, but I would just keep finding problems online and practicing them, and they are all the same.